Hello everyone. This video aims to revise preparation of amines and properties of amides. So let us start first with the preparation of amines. Amines can be prepared from two different kinds of reactions. One is a nucleophilic substitution reaction. The other one is reduction reaction. So for the nucleophilic substitution reactions, we are going to have halogenoalkanes as the main reactant. The reduction can be done from two different compounds. One, amides can be reduced to amine, and nitriles also can be reduced to amine. Halogenoalkane, it looks like any alkyl group connected to a halogen. Amide group, any alkyl group connected to C double bond O NH2. Nitrile, any alkyl group connected to C triple bond N. So let us first start with the nucleophilic substitution. Nucleophilic substitution. So as I said, we are going to take halogenoalkane, which is the reactant, which reacts with ethanolic ammonia, which is a nucleophile. Ethanolic ammonia, which is a nucleophile, and we are going to use heat, and the reaction takes place under pressure. So this is the reaction condition, which will give you a primary amine. And a hydrogen halide. So that is what we are going to have. So let me take as example, if I say R is any alkyl group and bromine is the halogen, and ammonia I write like this. Then I say heat under pressure. What you are going to see is, you are going to see the removal of HBr. I would say this is removed. So what you will write is, you will write R N H H plus what is removed is HBr. So if I replace this R group by CH3, then this is called as methyl bromide or bromomethane. Systematic name is bromomethane, and I am treating this with ammonia. I write like NH3 simply, and the reaction takes place in ethanol. You do heating and you use pressure, so you will get CH3NH2. This is methylamine, and hydrogen bromide. So this is ammonia, which is a nucleophile. So this reaction is nucleophilic substitution reaction, and the amine formed is primary amine. This is a primary amine. If suppose I want to form secondary amine with the same nucleophilic substitution, I can take again halogenoalkane and I combine with primary amine. Here the primary amine acts as a nucleophile, and you will get secondary amine and hydrogen halide. So for example, I take CH3Br again. Let me say this is methyl bromide or bromomethane, and I am taking a primary amine like CH3NH2, which is methylamine here, which is acting as a nucleophile. Now you are going to get CH3NHCH3 plus HBr. So this is methylamine. So I'm sorry, I can say the other way. It's not N-methyl, it is dimethylamine. It is dimethylamine, which is a secondary amine. So this is these are all the two reactions which gives primary amine and secondary amine. When I go for the next one is reduction. Reduction means addition of hydrogen or removal of oxygen. So we are going to take two different compounds to reduce. The first one is I am going to take amides. When I take amide and I use hydrogen, and I can say in presence of nickel as the catalyst, I can use otherwise I can use lithium aluminum hydride, which is a reducing agent. This is the reducing agent, which leads to primary amine. and water. So let me take amide. Already I told you amide has a functional group of C double bond O NH2. I have hydrogen. It is from the reducing agent. So this is ethanamide. The hydrogen is going to get added across the carbon double bond O. So you are going to have CH2. And the oxygen will be removed as water. So totally you are having these two hydrogens and these two hydrogens are from this hydrogen, from the reducing agent. So totally how many hydrogens? 4. So always the reducing agent is represented as square bracket H. So what you got is, you got ethylamine. You got ethylamine, which is a primary amine. If you have a substituted amide like this is a substituted amide. This is N-ethyl because, N-methyl, because the methyl group is attached to the nitrogen. So N-methyl ethanamide. Again, it can take hydrogen from the reducing agent, lithium aluminum hydride, otherwise tetrahydridoaluminate, lithium tetrahydridoaluminate, lithium tetrahydridoaluminate. So it will be converted again, the same kind of work. The oxygen will be removed from the double bond. Instead of that, you will have hydrogen added and the oxygen will go out as water. Again, I told you these two hydrogens and these two hydrogens come from here. So totally 4. The next one is about reduction of nitriles. Reduction of nitriles. Nitriles, I told you, they are having a structure like this, C triple bond N. I can use hydrogen in presence of nickel, which is a catalyst. You may get RCH2NH2. You are getting a primary amine. The R can be any alkyl group. This is nitrogen. Let me take a simplest one. This is ethane nitrogen. If I use hydrogen in presence of nickel, I'll get ethylamine, which is a primary amine. So nothing will be further formed. It's a addition reaction basically, and it is a reduction reaction also. So you will not get any other product. So this is ethylamine, which is a primary amine. You can use in place of nickel lithium aluminum hydride or else LiAlH4 also as the reducing agent. I hope you got some idea about how to prepare primary amines, secondary amines from amides, nitriles and halogenoalkanes using different reactions. Thank you for watching.